All right, Unit 1, Objective 1B, it's parent graphs again. Just wanted to separate it so it's not too long. So you got your essential question, how do you write the equations of a function when given a graph? So you'll see we're going to write equations today. Still very simple. First thing though, we didn't quite graph everything. So we graphed the 4, now we have our 2 special cases. They're technically linear, they're lines. So we have a horizontal line versus a vertical line. So horizontal line is y equals. Vertical line, x equals, and then a number. Okay, h and k, you'll see when we start shifting where those are coming from. Okay, that's why they have these weird letters h and k. We talk about our h as our left-right shift, our k as our up-down shift, and that's where those things are coming from. So don't worry about that too much. It's just when you have y equals and then a number, so no variable. That means we have a horizontal line at y equals 2. Let me zoom in real quick. So horizontal means flat like that. That's my horizontal line at 2. And one way to remember is y equals, notice it crosses the y-axis. So that's how we remember y equals horizontal, because the horizontal line crosses the y-axis. Okay? And then we have vertical line, same idea. 2, 3. X equals -3. Right there. So it's vertical. X equals always gives you a vertical. It's a number, no variable, just a number. So x equals a number. And one way to remember is, notice the vertical line goes through the x-axis. So if you're whatever axis you're going through, that's what you need, either x equals or y equals. Okay. Then we have domain and range. Domain is x values, all the x values that our function deals with. A lot of the time, that is all real numbers. If there's arrows, it's usually all real numbers for domain. Range can vary depending on the shape, because we have ends and stuff. Range is the y values. But you'll see we're going to get a little more complicated from what you've done. So everything you've done has been inequality notation. We're going to learn interval notation. So I'll show you both. But past chapter 1, we're going to use interval notation in this class. So you got to get used to this. So we're using interval notation. Only chapter 1 can you use inequality. Okay. So whether you like it or not, you got to figure it out how to use it. That's the whole point of this, is how to use it. Okay. So we have brackets versus parentheses. So brackets, sometimes they're called square brackets. They mean the same thing as a parenthesis, but in interval notation, these brackets means we include the point. So we'll talk about that. Parentheses, when you do not include. Okay? And you can have one of each. You could have both the same. So brackets include, parentheses do not include. We always use parentheses for a positive or negative infinity, so that's the infinity symbol, if you didn't know. So we can have a positive or a negative infinity. Positive infinity is up and right. Negative infinity is left or down, depending on which domain or range you're talking about. Domains are left to right, ranges are up and down. Okay, you always do the smaller number, comma, the larger number in this notation. And we use a U, it's called a union, to connect intervals. So this is called a union. We never write the word union, we just do the little U. Okay, so that means if there's more than one piece. Okay, so what we're talking about is what you've seen before is in inequality notation. So this is the old stuff. Okay, I'm only going to do these first two like that. So when we did domain and range, in interval notation you looked at, domain is left to right. So how far left and then how far right does this function go? Remember, these arrows mean they continue forever, so I'm going forever to the left, forever to the right. So that would be all real, which usually you just wrote this symbol. It's a weird looking R. Okay, that means all real numbers. Range, we think how far down to how far up. So these arrows are pointing down, so it's going to go down forever, but notice we have a point right here. That's the highest this graph ever goes. Okay, so that is at the y value, because remember range is y value of 3. So my y values are less than or equal to 3. That equals to means it's included. That's an important piece, right? We do actually get up to 3, but that's the highest we go. So the next thing is a little v. So we have domain and range, left to right. So it's going left forever and right forever. So all real numbers. Range, I'm going up forever now, but I'm going down to a y value of 1, 2, 3, 4, -4. That's my lowest I go. So my y values are greater than or equal to -4. Okay, now the next two we'll do in interval notation. Okay, so in interval notation, we have an asymptote here. So remember, we can't cross that. So this graph will never go below that value. But it is pointing to the left. So it's going to the left forever. It won't go down past that, but it is going to the left. The up arrow is also kind of pointing to the right. So it's also going to the right forever. So it's all real numbers. But instead of all real numbers, we say it's going from -infinity to positive infinity. Remember, infinity means forever. So I'm going left forever, -infinity, right forever, positive infinity. The range, however, we are going up forever, that's for sure. We got to start with how far down we're going. We always go down to up. So domain is always left to right. Range is always down to up. Okay. So I'm going down to 1, 2, 3, 4, 5. That's -5. But remember, we never actually cross that. We get really, really, really close to -5, but never actually to the value. That's the definition of asymptote. We never get there. So this is where the brackets versus parentheses comes in. So I'm going to use parentheses -5 to infinity. And we always use parentheses for infinities. Okay, you'll see on some of the next examples where we use brackets. Okay. So the next one, it's a line. These guys are easy. Domain, I'm going left and right forever. So all real numbers, which is -infinity to positive infinity. Range, I'm going up and down forever, down to up. So -infinity to positive infinity. There's no ending point. And then we can get to a little bit crazier things. So notice an open dot, like here on the left side here, that means it's not included. A closed dot means it is included. So when we're talking domain and range with these more complicated ones, we got to really think. I'm going to do all of these in interval notation, no more inequality. Those first two are the only inequality. Okay, so I have an open dot means I'm not including that. Remember, I'm going left to right. And then I'm including every x value, right? Every x value is included until I get to the next open dot. So in parentheses, I'm going from 1, 2, 3, 4, 5, -5 to +2. I'm including every single x value in between there. But my graph continues after that. So that's where the union comes in. And I pick up right where I left off, +2. Right? I'm just skipping that one number, so I'm getting really, really close, but it's parentheses because it's not included. And then where do I go to? So it's 1, 2, 3, 4. 6, +6. This one is included, so that's where we use a bracket. The range, so how far down? So this is the lowest I am going at. -1, not included anywhere in this graph, so I use parentheses. Then I go up. Okay, this one throws some people off. If it's included anywhere, we're good. We're including +2, y value of 2. We're not including it there, but we are including it right here. And we're including it right here. So it is included, so we can keep going. There's no problem yet. Then we go all the way to the top. So that's 1, 2, 3, 4, 5, 6, including the 6. It's a closed dot, so it's part of our graph. Okay, next one, notice we have an arrow now. So for my domain, where I'm talking left to right, this is going left forever. Then we get to an open dot here, so it's -infinity to -2. Then I'm going from -2, I'm including all of these values until 1, 2, So from -2 to 5, but not including because I have holes on both of those parts, so parentheses for both. Range, how far down? So that's the furthest I go down, 1, 2, 3, 4, 5. -5, not included. And how far up? This goes up forever. Once again, there's a hole here, but notice this -1 y value is included lots of other places, so we're including it, so it's going to go up to infinity from -5. Okay. This one has an asymptote with arrows on both ends now. So domain, this is going left forever until I get to this hole at -2, so negative infinity to -2. Then I'm going from negative and 2, and I'm going arrow, so to infinity. Range, how far down? Okay, this throws people off. That's a hole, right? But what does this arrow mean? It means it continues. Don't be fooled by that. So this does include everything below. So I'm going from negative infinity to every y value is included because of that arrow until I get to my asymptote, which is at 1, 2, 3, 4, 5. Remember, asymptotes means we can't cross. So that's the highest we're going to go, not including. We never quite get there. And the last one. Okay, so I'm including 1, 2, 3, 4, 5, -6 to 1, 2, 3, 4, 5. Oh, sorry, wait. 2, 3, 4, -4, not including. That's my hole. Then pick right back up, -4 until the very end, which is 1, 2, 3, 4, 5, 7, not including. Okay, range, how far down? This is the lowest point, so 1, 2, 3, 4. -4 including now, because it is closed. How far up? So this throws people off, but remember it's included somewhere else, so we can keep going. Everything, all the y values are included somewhere until I get to this point right here. 6, and that one's not included. Okay, so things to remember. Domain, you always go left, start with the leftmost to the rightmost. Okay, look at what do we include all the values in between. Oops. Range, we always start with the low, I'll say down, then we go up to the highest, up. So down, left to right, down to up. You always go in those directions. Domain, always start at the left, move to the right. With range, always down, start down, move up. And remember, where we're starting, the left and the downs, those are the negative infinities if they go forever in those directions. If we're going right and up, those are the positive infinities if we're going forever in those directions. So we have writing equations now. We're going with simple. Okay, so we have y equals mx, that's our linear. Y equals a absolute value x, that's our absolute value. Y equals ax squared, that's our quadratic. And y equals b to the power of x, that's our exponential. Okay, no plus b's, no pluses and minuses, starting simple. Okay, so you should see our key point on every single one of these, and you see it, 0, 0 for the first 3, and then 0, 1 for that one. We always look for those key points first. So let's start with the linear. Okay, we got to count slope. We always start with the left side, so I'm going to go to this point on the left side and rise over run. I went up 1, over 1, 2, 3. So my slope is positive 1/3 because I'm increasing, so it's positive, and rise over run. Got that. I'll write this out. And with that, that's all we really need. We can write the equation, y equals 1/3 x. It's that simple right now. Okay. For the next one, we got to tell, is it positive or negative? Remember, up is positive. If it's going down, it's negative. So this one's going up. So it's going to be a positive value. And this one, we can actually use slope again. Whenever it says linear in it, that's when you know it's slope. Linear absolute or linear. So we can use rise over run. So my a value, start with the left, go to the right. So 1, 2, 3, 4. 1, 2, which we can simplify. 4 divided by 2 is 2. So I get y equals 2 absolute value x. Did it. Okay. Those are the easy ones. Quadratic is a little more difficult. Okay, so we have this. We have our key point, that's good, but we can't count. We can only count for slopes. So my a value, I have to solve for. We still have up is positive, down is negative. That's still true. But a, we need to solve. So how we solve is we plug in the extra point. So we don't ever use our key point. We use the extra point. So 1, 2, 3, 1, 2. So 3, 2 is my extra point. So we're going to plug that in to the equation. So x is 3, y is 2. So 2 equals a times 3 squared. So 2 equals 9a, 2/9 equals a. Right, square it, then divide. I guess I should show that work. Divide by 9 on both sides. That's where I did that. And so I get y equals 2/9 x squared. This gets a lot more complicated later. Right now it's pretty simple. We gotta solve. There's no way around it. Exponential, same thing. We have to solve. There's no way around it. Okay. So b, we need to solve. So once again, we don't use the key point, we use the extra point. There's always going to be one more. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 3, 8. Okay, always count from the origin as well. Don't count from the key point, count from the origin to find your coordinates. So x is 3, y is 8. So 8 equals b cubed. Okay, so you have to know how to solve this. We could take the cube root of both sides, or we can think what cubed, b cubed, what number cubed is 8? So I know that 2, when I cube it, makes 8. So that would be y equals 2 to the x. Once again, that gets more complicated. So you got to realize when you can count slope, that's the straight stuff, right? The line, linear things, that's when we can just count slope. It makes it really easy. And when you can't, the curves, we cannot count slope. It's not linear, so we can't count slopes. We got to plug in to find the values. Okay? And then we can solve for some equations. So I'm just going to count slope in any linear thing. So down 1, 2, 3, 4 over 1. So I have negative 4 over 1. Y equals negative 4x. It's a linear function. Okay. Next one is one of our special cases, right? So we have to think it's going across the y-axis. So it's going to be y equals, and it's at 1, 2, 3, negative 3. Y equals negative 3, right? No variables. Don't forget that. Okay, these guys are linear again, so I can count. But we got to pay attention, up versus down. So this is down. So that means it's going to be negative. 1, 2, 1, 2, 3, 4. So a equals 2/4, which simplifies to 1/2. Y equals negative 1/2 absolute value of x. It's going down. Got to be negative. Same thing here. It's going down, so it's going to be negative. And we just count. 1, 2, 1, 2. So a equals 2 over 2, which is 1. So y equals negative 1 absolute value of x. Or you could have just written negative absolute value of x. Same thing. Then we have the ones that take a little more work. So we have extra point. 1, 2, 3, 4, negative 4. 1, 2, 3, 4, negative 5. So I have negative 5 equals a negative 4 squared. So negative 5 equals 16a. Divide both sides by 16. And I get negative 5/16 equals a. And that's my equation, negative 5/16 x squared. Make sure you're using the correct forms. U shape should be squared, linear should be x, special cases should have no variable, absolute values should have absolute values, exponentials should have x in the exponent. Okay, next one. So 1, 2, 1, 2, 3, 4, 2, 4. 4 equals a 2 squared. 4 equals 4a. Divide. And I get 1 equals a. So y equals x squared. Right, 1x squared is the same as just x squared. These guys, they already gave you the thing, so I have my point. So it's 27 equals b cubed. So 3 equals b. If you didn't know, 3 cubed equals 27. So y equals 3 to the x. It's an exponential, so my x is in the exponent. So in this next one, my extra point, don't forget, you use the extra point, not the key point. So I have 100 equals b squared. Square root both sides, so I get 10 equals b. Y equals 10 to the x. And there we have it. So we have domain and range, we have our special cases, and we have writing equations. So I'll let you work on your 3-sentence summary.